Hello, grade 12 learners. I hope you're okay. If you are new to the channel, please don't forget to subscribe. If you're a regular here, thank you for coming back and taking your time to view the channel. I hope the videos are helping you. Okay, today I'm going to focus on calculus. Are you together? But before we even get deeper into calculus, let's learn how to find the limit of a number. A limit of a number. If I have my expression like this, I must find the limit of x. This thing simply means that whenever I see x, I must substitute this guy. Are you together? So simply means my answer will be A. Are you together? For example, let's say I have a limit of x as x approaches, the limit of x as x approaches 2. This thing simply means I will substitute 2 whenever I see x. Are you together? So therefore my answer will be 2. Does it make sense? And a limit of any constant, guys, a limit of any constant term, a limit of a constant term as x approaches a is always equal to that constant. Are you together? If I want to find the limit of 3 as x approaches 5, this 3 will never change. Why? Because it's variable. It does not have x as its variable. Are you together? It does not depend on x, so it will just stay constant as 3. And then another thing I want us to know is that a limit to infinity a limit of c over x as x approaches infinity will always be equal to 0. Why? If c represents a constant term, this thing will be always equal to 0. For example, if I have a limit of x, a limit of 3 over x as x approaches infinity, why am I saying I'll get a number which is closer to 0? Because if I can draw this graph, 3 over x, it's a graph like this. It's a graph like this. Y 0 x-axis. As the graph continues until infinity, the graph gets closer and closer to 0. Hence, I said my limit will be 0, nothing less than a 0. Are we together? Okay. I wanted us to find to know how to find the limit, because whenever we find a derivative by using first principle, we will use the limit laws. Are we together? Finding the derivative one day I'll improve my handwriting, I promise. Finding the derivative by using first principles. It's so simple. All you need to do is to use this equation. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus minus f of x. This thing is divided by h. Let's get. So we always use this equation to find the derivative. If you have a situation like this, f of x is equal to x squared plus 3x, I'm asked to find the derivative. I will use my equation. I know that f prime of x will be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Whenever I say f of x plus h, it simply means that on f of x, whenever I see x, I must put x plus h. Now together. So whenever I see x, I must put x plus h. So I will have x plus h all squared plus 3 multiplied by x plus h. And then I still need to subtract what? F of x. And f of x is x squared plus 3x. This entire thing is divided by h. The aim here, guys, is to substitute 0 whenever I see h. Are you together? But right now I cannot do that. Why? Because h is at the denominator. Whenever I substitute 0 here, this entire thing will be undefined. Are you together? So now my goal is to try to get rid of that h at the denominator. Okay, and then whenever I remove the brackets on top, I will have x squared plus 2xh, and I'll have h squared. The second bracket will give me 3x plus 3h. Are you together? And remember that I'm subtracting f of x here. I'll have negative x squared minus 3x. This entire thing is divided by h. Please note, I will keep on writing limit as h approaches 0 until I substitute 0 whenever I see h. So if I haven't substituted 0 whenever I see h, I'll keep on writing this thing. This guy and this guy will subtract one another, and this guy and this guy will subtract one another. Are you together? I made a mistake here. It was supposed to be h, because 3 times x is 3x, 3 times h is 3h. Okay, then therefore I'll be left with 2xh plus h squared and 3h here. This thing is all divided by h. I can therefore take out a common factor at the numerator, which is h. I'll be left with 2x plus h and 3 all over h. The h's will cancel one another, and then I'll be left with what? Limit as h approaches 0 of 2x plus h plus 3. Now whenever I see h, I will substitute 0. Please note that whenever I substitute 0, I no longer write limit as x approaches 0, because now I am substituting it. All right, together, and then therefore the answer is 2x plus 3. That's how you find the derivative by using first principles, guys. Always use this equation, find f of x plus h, then you subtract f of x from it, then you must remove h at the denominator and then substitute. Please pause the video and try this on your own. Pause the video and try this on your own. F of x is equal to x cubed. Pause the video and try it on your own. F of x is equal to x cubed. Okay, I'll still say, for me to find the derivative, which is f prime of x, I need to say limit as h approaches 0 of what? F of x plus h minus f of x all over h. Whenever I see x, I must put x plus h, and then I need to substitute my f of x. Okay, now I need to I can open 3 brackets and multiply them all together, but believe me, you will get x cubed plus 3 x squared h plus 3x h squared plus h cubed. Then you still have to subtract the f of x. This entire thing is divided by h. This guy will subtract this one. I will be left with 3 x squared h plus 3x h squared all over h. Then I must try to remove the h at the denominator. I must take out a common factor at the top. I'll have 3 x squared h. No, I'll just have 3x squared plus 3 xh and h squared all over h. This will cancel this, and then I'm left with limit as h approaches 0 of 3x squared Please note, whenever I substitute 0 as my h, I no longer write limit as h approaches 0. Whenever I do this, I no longer write that. So my answer will be just 3x squared. Are we together? The problem for many students come whenever now we have fractions. Find the derivative. It's simple as well, guys. You need to say f prime of x is limit as h approaches 0 all over this thing is all over x now. H approaches 0, not x. Whenever I see x, I must put x plus h. Are we together? Whenever I see x, I must put x plus h. Okay, whenever I deal with fractions, guys, I don't want to have fractions within a fraction. Are we together? I want to have whole numbers divided by whole numbers. So for me to get rid of this fraction, I must multiply the top and bottom with an LCD that will accommodate both the numerator and the denominator. So my LCD, since I have two different denominators, I'll just multiply them together. I'll have x and x plus h. Whatever I do at the top, I must do at the bottom. And then now whenever I multiply the first term, this one, by the LCD, the brackets will cancel this denominator. I will be left with x minus the second term multiplied by the LCD. The x's will cancel and I'll be left with x plus h. At the denominator, I'll just have h, x and x plus h. like this, and then I need to remove the brackets. Okay, now before I remove the brackets at the numerator, guys, we can all see that I have whole numbers divided by whole numbers. It's easier for me to work whenever I have this kind of a situation. So I will have x minus h. This thing is equal to is divided by h times x and x plus h. So I still have limit as h approaches 0. The two x's will subtract there at the top. I'll be left with negative h all over h times x and x plus h. The two h's will cancel. I'll therefore have limit as h approaches 0 of a negative 1 all over x and x plus h. And then now I can substitute h as my 0, because when I do that, even though h is at the denominator, the entire denominator will not be 0. So I can substitute h as my 0 now. So I'll have negative 1 over x times x plus 0. Let me write a 0 in different color. Plus 0. And then I'll be left with a negative 1 over x times x. I'll get x squared. That's how my answer should be. Are we together? So whenever I given a fraction, this is how you should answer. Let's do another one. In either one, f of x is equal to 1 over x squared. Same thing applies, ne? Limit as h approaches 0 of f of x plus h minus f of x all divided by h. What do I get? A 1 over x plus h all squared minus 1 over x squared. This entire thing is divided by h. Whenever I deal with fractions, I don't want to have fractions within a fraction. So what I'll do is to multiply the top and bottom with an LCD that accommodates both the numerator and the denominator. So I'll have x squared and the bracket x squared and the bracket whenever I multiply the first term by the LCD, I will be left with x squared. Whenever I multiply the second term by the LCD, I'll be left with the bracket. And then there at the bottom, I will have h times x squared in the bracket. Okay. Now I need to remove the brackets at the numerator. Are it together? I'll have x squared minus x squared minus 2xh and minus h squared. This entire thing is divided by h x squared and then x plus all squared. Now I have whole numbers divided by whole numbers. It will be easier for me to work. Are we together? The two x squareds will cancel one another. I will be left with I'll be left with 2xh minus h squared. It's divided by h times x squared, and then x like this. And I can take out a common factor there, which is h. I'll be left with negative 2x minus h over h and then the h's will cancel. Please note that I still write limits as h approaches 0. I'll keep on writing it until I substitute 0 whenever I see h. Are you together? Please note, now I have limit as h approaches 0, negative 2x minus h is divided by x squared, x plus h all squared. Whenever I see h, I can put 0 there. So I'll have negative 2x minus 0 over x squared, x plus 0 squared, like this. Are you together? Please note that since I substituted 0 as my h, I didn't write limit as h approaches 0. So therefore I'll be left with negative 2x divided by x squared times x squared. This thing is the same as negative 2x all over x to the power 4, which will give me negative 2 over x cubed. So that's my derivative. Are you together? If f of x was 1 over x squared, therefore my derivative will be negative 2 over x cubed. Are you together? So that's how you find a derivative by using first principles. Are you together? It's simple. Whenever you see x, you must put x plus h, then simplify, and then after that you must substitute 0 whenever you see h. But you cannot substitute 0 if whenever you do that, the entire thing will be undefined. Are you together? So now let's learn how to find the derivative if we are given the rule. No, not if you are given the rule. By not using the first principle. Please note, if you are given f of x like this, as we just did there, let's say we have 1 over x squared, we know that our derivative will be negative 2 over x cubed. We just calculated it. Whenever they will ask you in the exam, they will say find f prime of x. This thing of f prime of x simply means derive with respect to x. Only derive the things that have x. Anything that does not have x is regarded as a constant, and the derivative of a constant is 0. Are you together? So if ever I have something like this, f of x is equal to 2x cubed plus 3x plus 4. I know that my derivative, you can do it by using first principle. You should find 6x squared plus 3. The derivative of 4 will give me 0. So this will be my answer. Are you together? I can just do that by not using first principle either, by just using the rule. The rule says if f of x is equal to a x to the power n, therefore the derivative of x will be equal to, you'll just take the exponent and multiply it to a and then subtract 1 from the exponent. That's how you find the derivative. This is the rule we use to find the derivative. Are we together? And please note that the derivative of a constant is 0. Are we together? The derivative of a constant is always equal to 0. So let's say let's have examples. Let's say we have f of x is equal to 6x cubed plus 2x squared plus x minus 4. Determine the derivative. You don't have to do first principle if they didn't ask you to do so. Are you together? You'll get to the same answer. First principle, you are just taking a longer route. So you'll say you'll just use this rule. Are you together? For everything that has x. So what will I say? I'll say 3 times 6. I'll say 3 multiplied by 6 x3, and then I need to subtract 1 at the denominator, not denominator man, at the exponent, plus do the same thing, take the exponent, put it in front, and then you'll have 2x, still have a 2, but now you must subtract 1. Are you together? And then for this one, my exponent is 1. Are you together? So I'll say 1 multiplied by x, 1 minus 1. And then here, the derivative of a constant is 0. Are you together? So my final answer will be 3 times 6 will give me 18. X to the power 3 minus 1 is 18x squared. Are you together? And then 2 times 2 is 4 to the power times x to the power 1, because 2 minus 1 is 1. Are you together? And then here I will have 1, because x to the power 1 minus 1 is x to the power 0. Anything to the power 0 is what? Will give me 1. So this will be my derivative. Are you together? But yeah, before we find the derivative, there are certain steps. I was just showing you an example. There are certain steps that we must take into consideration. I cannot find my derivative if I have surds, brackets, and fractions. Are you together? Let's do the one of surds first. How to deal with finding the derivative if we have surds. F of x is equal to the cube root of x to the power 4. Find the derivative. Please note from the laws of exponents, the root is always the denominator of your exponent. Are you together? So in this case, before I find my derivative, I must first remove the surd. So I'll say x to the power 4 divided by 3. This 3 is this one. Are you together? And then now I can find my derivative. I'll therefore say f prime of x is equal to 4 over 3. And then when I say 4 over 3 minus 1, what will I get? I'll get 1 over 3. This will be my derivative. Please do this one. Pause the video and do it on your own. If you have f of x equal to the square root of x cubed, find the derivative. You'll simply say f of x is equal to x to the power 3 over 2. Please note that I only write f prime of x on the final answer. Are you together? Whenever I'm finding my derivative, that's when I'll write my f of x. But before I find my derivative, I wouldn't write f prime of x. I'll therefore say f prime of x. When I write f prime of x, then the statement on the right hand side has to be me finding the derivative. Are we together? So I'll simply say it's 3 over 2 x to the power 3 over 2 minus 1. I'll get 1 over 2. That's my answer. So whenever I have surds, I need to remove them by using this exponential rule. Are you together? And then whenever I have brackets, if f of x is equal to, I need to remove the brackets first. Are you together? So I'll simply say f of x is equal to x squared plus 4x plus 4. And then I know that f prime of x will be equal to what? 2x plus 4. Please note, I only write f prime of x when I'm finding my derivative. Are you together? How did I get 2x plus 4? I said 2 multiplied by x, I got 2x, then 2 minus 1, I got 1 is the exponent. The exponent here is 1, so 1 times 4 is 4, and then x to the power 0 is 1. I don't need to write x to the power 0. This is how I find my derivative. And then whenever they say remove fractions, if you have a situation like this, 1 over x plus x over 2, you only remove the fraction of what you are deriving. Are you together? My aim is to derive x, not 2. 2 is just a constant term. So what I will do is to remove x from the denominator. So I'll simply say there's a rule of exponents that must apply here. Né? If I have 1 over a to the power p, for me to remove a to the power p at the denominator, I just need to change the sign of its exponent. Its sign here, the sign of the exponent was positive, now it's negative. So what I'll do here is that I'll have x to the power negative 1 plus 1 over 2x. X over 2 is the same as 1 over 2x, né, guys? I haven't found my derivative, so I'm still writing f of x. Now I don't have fractions. I can simplify my derivative. So I'll say minus 1 times x is negative x. Then whenever I subtract 1 from a negative 1, I'll get a negative 2. Are you together? And then here I'll still have 1 over 2. I can leave my answer with positive exponents. It's not necessary, but if ever I'm asked to do so, I'll still apply this rule. That's whenever I move my number here as a numerator to write it as an exponent. This side, to write it at the denominator, the sign of the exponent has to change. So I'll simply say minus 1 over x squared. I still have half there. That's my derivative. Are you together? Please note, sometimes you won't be given equations, but you'll be given expressions. Are you together? The examiner can be like dx of 2x squared plus the square root of x to the power 5. You must know that this thing just tells you to find the derivative of what's inside the brackets. Are you together? This dx instructs you to find the derivative of what's inside the bracket. Are you together? So what I'll do, I will write my dx here and then remove the set first. I'll have 5 over 2. Are you together? And then whenever I find my derivative, I don't need to write the dx because the dx is the one that's giving me the instruction to find the derivative. Are you together? Right now I'm finding the derivative. I'm no longer writing dx, I'll just find the derivative. So I'll write 4x plus 5 over 2 x. 5 over 2 minus 1, I will get 3 over 2. Alright, together. I can leave my answer like this, or I can leave it in set form if I want to. So I'll have 4x plus 5 over 2 multiplied by the square root of x cubed. Please note that the root is always the denominator of the exponent. Are you together? Sometimes you're not given an equation, but you're given an expression. D of dx is equal to 1 over x squared plus 3y multiplied by x to the power 7. Find the derivative. I can't find the derivative if I have fractions together. I must remove the fraction first. Before I find the derivative, I'll keep on writing d of dx, because d of dx tells me to derive everything that has x. Derive everything with respect to x. Anything that doesn't have x is a constant. So the derivative of that thing will be 0. Are you together? So right now I'll have x to the power negative 2 plus 3y and x to the power 7. Are you together, guys? So here all we need to do is to find the derivative. I no longer have fractions, I don't have sets, and I don't have brackets. Are you together? So now I need to find my derivative. Please note that whenever I write my derivative, I no longer write d over dx, because d over dx is what was instructing me to find the derivative. Are you together? So I'll simply say this will give me negative 2x to the power negative 3, because I still have to subtract 1 there. This one will give me 0. The derivative of a constant is 0 plus 7x to the power 6. I can leave my answer like this, or I can write it with positive exponents. That means I'll have negative 2 over x to the power 3 plus 7x to the power 6. That's how you find a derivative, guys. Are you together? So now I've found the derivative. The next video that will follow, it will be me doing application of calculus. Doing the application of calculus. Oh, but let me do one of them before I go. The one of a tangent. Maybe the question will be like, find the equation of a tangent to the curve. Let me write the equation of a curve. Let's say it's x squared. F of x is equal to x squared minus x minus 6. Find the equation of the tangent to the curve at x is equal to 1. Okay. A tangent is a straight line, guys. For me to find the equation of a straight line, I need to have two things. I must have the gradient of that line and the point on that line for me to find the equation. Right, together. Now I only have the x value. I can use the equation to find the corresponding y value. Are you together? So since I know that solution, I know that f of x is equal to x squared minus x minus 6. Simply means that f of 1, I'll just put 1 there. Whenever I see x, I put 1 for me to find the corresponding y value. I'll have 1 minus 1 minus 6. I'll have negative 6. This thing simply means that my point of contact between the tangent and the curve is 1 and negative 6. All I'm left with is to find the gradient. How can I find the gradient? Please note that, guys, the derivative of a curve at a specific x value is equal to the gradient of a tangent at that x value. So this thing simply means that my f prime of x is 2x minus 1. Are you together? So I can find the gradient of a tangent when x is equal to 1. This thing simply means whenever I see x, I'll substitute a 1. 1, 1. What do I get? I get 1. Are you together? Now I know that, okay, my gradient is 1 and my point is 1 and negative 6. Are we together? I'll therefore use my equation whereby y minus y1 is equal to mx minus x1. So therefore I'll simply say whenever I see y1, I'll put this guy, x1, I'll put this guy. M is the gradient. So y minus y1, which is negative 6, m is the gradient, then I'll have x minus 1. I have y plus 6 is equal to x minus 1. Y is equal to x minus 7. The equation of my tangent would be this one. Are you together? This tangent, this equation, this line x minus 7 is a tangent to f of x when x is equal to 1. Are we together? That's how you apply the calculus whenever finding the equation of a straight line. Are we together? Before I go, here's one for the road. You must find the equation. Find the equation of a tangent to the curve f of x is equal to x cubed. At the point of inflection. Okay. Find the equation of the tangent to the curve at the point of inflection. Now my curve is vague. Let me draw it like this. Let me change the equation, guys, because this one is 0. The curve is f of x is equal to x cubed plus 2x minus 3. Yeah. I'm supposed to find the equation of a tangent to the curve at the point of inflection. Are we together? How do I get the point of inflection? For me to find the point of inflection, I must always make the second derivative to be 0 and then solve x. Are you together? Okay, if f of x is equal to x cubed plus 2x minus 3, simply means that my first derivative will be 3x squared plus 2. Are you together? And my second derivative, please note that for the second derivative I have the double prime there, né? My second derivative is what? Is 6x. For me to find the point of inflection, I need to say second derivative is equal to 0. Simply means that 6x is equal to 0. If I divide both sides by 6, therefore x will be 0. Now I know the x value at the point of inflection. I need to find the corresponding y value. Are we together? The corresponding y value will be f. For me to find the y value, I must substitute there at the original graph. Are we together? So when I figure 0 there, I'll have 0 cubed plus 2 times 0 minus 3, and then this guy will give me a negative 3. So now I know that the point that I have, my point is 0 and negative 3. And then now I must find the gradient. Are you together? For me to find the gradient, please note, guys, the gradient of a tangent to the curve is equal to the derivative of a curve at a specific point. So I know that my f prime of x is equal to 3x squared plus 2. I do know the value of my x. So I'll just substitute 0 whenever I see x, and then what will I have? I will have 2. Simply means that my gradient is equal to 2. Are you together? So therefore, I have a gradient in a point. I'll go and use my equation. Y minus y1 is equal to m minus x1. y1 is negative 3. M is 2. I have x minus 0. Y plus 3 is equal to 2x. Therefore, y is 2x minus 3. This is the equation of my tangent at the point of inflection. Are you together? So this is how I deal with finding the equation of a tangent, guys. Please stay tuned, guys. Wait for more videos, subscribe, tell the others to come and learn here. Thank you, guys.